Now we got a few more examples of adding and subtracting rational expressions to show you. These last few examples, this really I think is probably the heart of the matter in terms of the challenge, the difficulty level. This is what you're striving for as you are trying to master this topic. The previous examples have been good at illustrating what to do. They're showing you basically the process that you need to go through. It's just that they're relatively simple in nature. They're not taking too long to get through. These last few examples are going to push the envelope a bit and require a little bit more from you to get through them. A bit of perseverance, tenacity. You got to hang in there. And of course, you got to get things right, because if you make a mistake, it's going to snowball through the problem and really foul things up. So they can be quite frustrating as well. Nevertheless, the process is the same. You're going to get a common denominator, the LCD, and then from there bring the two fractions together. And these examples, you'll start to see things happen that really hadn't been happening before, like a bit of simplifying the lowest terms, factoring and canceling, that sort of thing. I kept that stuff off the table at the outset because I don't want to make things too complicated too quick. I want to be able to focus on the process. Now that we've been through several examples illustrating the process, we're able to then throw a little more at you in these last few examples. All right, so here comes our next example here. And this one's not really that bad, but it is a little step up from what we've been doing. So, okay, that's what we're trying to do here. So here's the problem. And like the other problems, we want to get the LCD, but before we can run off and get that LCD, notice this second denominator here. Notice what's different about it. If you stare at that for a moment, you'll realize, okay, it's a little more complicated, but more specifically, it can be factored. And that, as a general rule, is what you want to do first. You want to factor all your denominators before you try to pick off the LCD, because otherwise, you're going to have a difficult time figuring out what that LCD is. But once you get this guy factored, it's not going to be such a big deal. So go in there and factor that denominator. And all it is, as you look at the denominator here, it's just a difference of two squares, right? M squared minus 1. That's the difference of two squares. M plus 1, M minus 1. Okay. Now that we got that thing factored, it really is a piece of cake to pick off your LCD. What's the smallest thing these two denominators will go into? Well, one thing's for sure, your LCD cannot be smaller than any one of your denominators. So if I was just to start with this, that would be required for that second denominator to go into. And then notice it has the first denominator already built into it, as it were. So this, in fact, will be the LCD. That is the LCD right there. M plus 1, M minus 1. I can't get any smaller than that, to be sure, because it's the second denominator is that big, but it has the M minus 1 already built into it. Sort of what I'm getting at with all that is that I don't need to have two of those M minus 1s. That'd be like that problem earlier where we had the two denominators of 3x and x squared. You know, I didn't need to do 3x cubed. I didn't need to multiply all together. I could just take 3x squared as my common denominator. That's sort of the same idea here. This M minus 1 that you see in the LCD handles the M minus 1 in that second denominator, also handles the M minus 1 in the first denominator. So it's sufficient. That's sufficient as the LCD for everything. All right. So let's go ahead and write it down as the common denominator for both pieces, just like we've always been doing. There we are. So far, so good. Now we play the multiplication game, just like before. So what am I going to multiply M minus 1 by to turn into M plus 1, M minus 1? Well, that's not too hard. You need the M plus 1, don't you? So just go ahead and throw that in there. And of course, when we do the denominator, do the numerator. Now on top there, there's a little bit of distributive property come into play. The 2m is going to distribute itself through, so we can go ahead and do that. Not that big of a deal. All right, so what do we got on top there? We basically get 2m times m is 2m. Oops, should have a black marker there. Not that it really matters too much, but keep color consistency. 2m squared plus 2m. And then what happens on the second piece? Well, it's already got everything, doesn't it? So I don't have to do anything to it. Leave it untouched. Just a 4 on top. Good. Now, we're going to bring it all together over one common denominator. So here's the one common denominator, m plus 1, m minus 1. And this is not too difficult to bring together. 2m squared plus 2m minus the 4 there. All right, so far so good. We've got the single fraction. But what's the remaining issue? Remember, we've always been talking about the goal is basically to bring the two fractions together over one common denominator, one fraction, and then also to make sure that it is in lowest terms. So you got to ask yourself, is this in lowest terms? Looking at it, we don't know. It could be, but we're not 100% sure, and that's the problem. You got to go in there and investigate. What does that mean? Well, it means do a little factoring and see if you can do a little canceling. So we want to factor that numerator. Is the numerator hard to factor? No, it's not hard to factor. Now, how do you factor that numerator? Well, you got to take a 2 out to begin with, right? There's a GCF of 2. So I'll take a 2 out to begin with, leaving behind an m squared plus m minus 2 there. So far, so good. And then what happens? Well, you got a reverse FOIL process. A little trinomial there. Shouldn't be too bad. I mean, this is not going to be that complicated. The denominator I'm not touching at all, so just put it down there. But the numerator, do the reverse FOIL. M squared, we get that by doing m and m. So that's to get the m squared, the f in FOIL. What about that 2 there? That's going to be a 1 and 2. And with the symmetry of the two m's, it doesn't really matter where you put things. All that really got to deal with here is where to put the plus and minus. Now, it's important you get it right, because if you don't put the plus and minus in the right spot, what will end up happening is you'll get the wrong cancellation. And that means the wrong answer. But you'll probably feel good about it, because, hey, it canceled. I must have done it right. You know, after all, if it doesn't factor correctly, it won't cancel right. So the fact that I canceled it must mean I did it right. Not necessarily. Because if you foul those signs up, it'll still cancel, but it'll be wrong. So let's make sure we get the signs in the right spot. We need a plus 1m in the middle. So you basically have a 2 for the O in FOIL and a 1 for the I in FOIL. That means to get a plus 1 in the middle, you want a plus on the 2, plus 2, and then minus 1. That'll give you the plus 1m in the middle. And, of course, the minus 2 at the end like you want. Now, what actually ends up canceling here? It's the m minus 1s, isn't it? That's the part that cancels. That's what's supposed to cancel. And so the final answer ends up being 2 times m plus 2 on top over m plus 1 down below. By the way, if you want to, you could rewrite this numerator by distributing the 2 through there. 2m plus 4 over m plus 1. Is there any reason to really do that? No, no compelling reason. Could you do it? Yeah. Will they do it? I don't know, right? Probably not, but they could, so I can't really give a hard and fast rule or answer to that. Both of these are in lowest terms, and that's what really matters. Whether they distribute the 2 on top or not, that's more or less irrelevant, other than, you know, they might do it, they may not do it, so just, you know, be a little flexible, right? It's like saying, you know, if you got an answer like, well, go back to dealing with fractions. If I have an answer like, say, 11 thirds, could they rewrite that as, say, 3 and 2/3? Yeah, which way will they write? I don't know. It just depends on what they feel like that day. If they wake up, you know, on a Tuesday, they write 11 thirds. If they wake up on a Wednesday, they write as 3 and 2/3. Who knows? There's no hard and fast rule about that. So just learn to be a little flexible, and you'll know whether you got the right answer, because you can usually convert one into the other. Okay, so that's a pretty good example there, at least getting the ball rolling here with some of these more challenging examples. You can see there's a little more to wade through, right? That's what I'm talking about. There's more stuff going on. There's more stuff that you have to do to successfully get to the answer. What does that mean? That means there's more opportunities for you to make a mistake, yeah? And that's what makes these problems more frustrating, because, hey, we all make mistakes. And so every once in a while you're going to be working a problem like this, and you're going to make a mistake, but you won't realize at the time. It's going to foul things up, and then you sort of get muddled down here toward the end, and it's not working out. And then you got to go through this tedious proofreading process of trying to find out where the error is. And that's not fun. And so these problems tend to be, well, among the more loathsome algebra problems you come across in the course, because they just require so much effort sometimes to successfully get all the way through them. They can definitely be among the more frustrating problems in the course. But they're not the entire course, so just do what you can and try to get through as many of them as you can. I'll put, you know, a couple of them on the next test or whatever, but don't make a mountain out of a molehill. They're not the entire course. Just do what you can with them, and you can still survive the class even if you can't become a master of adding and subtracting rational expressions. Let's run through another example here, just to keep showing you things to look out for, and, you know, how to work these type of problems. And try to give you as much little tips, tricks, clues, things that will hopefully give you as much advantage as possible to successfully navigate your way through these problems. All right, this next example is kind of interesting here. It's got a couple things going on that make it a little different than the others. I'm going to write it down here for us. most of the time, when you do a problem of this sort, you pick off your LCD fairly early. You might have to factor the denominators first and then pick off the LCD, but it tends to come in pretty early in the problem, within the first couple steps. In this particular example, we're going to delay a little bit getting that LCD for a good reason, as you'll see. The goal will be to ultimately keep that LCD as simple as possible. And anyway, you'll see how that unfolds as we do the problem. Now we're going to start by getting those denominators factored, because that's definitely the first place to begin here. Anytime you got denominators that can be factored, you want to go ahead and factor those, because that's necessary to get that LCD. So let's go ahead and do that. The factoring of the denominators is not difficult to do, but it's a necessary first step. X squared minus 9. That's a difference of two squares, right? X squared minus 3 squared. So x plus 3, x minus 3. Not too difficult. And then the second piece here, the 15x minus 5x squared, that's a GCF issue at the outset, right? Take the 5 and an x, right, as a GCF, 5 and x. 5x is a GCF. What's that leave behind? 3, because 5x times 3 is 15, minus, and then x there, because that'll be 5x squared. Okay. So far, so good. We got the denominators factored. Now, here's one of the things that's a little different about this problem I want to point out to you. And this is definitely something that you want to keep your eyes open for, keep on the watch for, because if you can catch it, it makes everything a lot easier down the road. Notice there's a connection between these two denominators. In some sense, there's something that sort of ties them together. What is it that ties these two denominators together? The x minus 3 and the 3 minus x. They're sort of related in a sense, like cousins. If we can make them identical, that's going to definitely work to our advantage. Why? Well, as long as they're different from each other, then both of them will have to be in the LCD, making the LCD more complicated. But if I can make them identical, they can say both x minus 3's, then only one of them has to be in the LCD, because one of them in the LCD will cover both bases. And that's really the way to approach these problems. So let's go ahead and make them identical. How? Well, we're going to use that trick that we saw a little while ago, the factoring out -1 trick. Let's use it to turn, say, this guy around. So let's factor -1 out of this. Factor out a -1 here. Out. Let me write that A a little better. Factor out a -1 here. There we go. That's going to spin that piece around, make it identical to the x minus 3 there. Now the first piece I'm not changing at all, so let's go ahead and just rewrite it exactly the way we have it. It's the second piece that I'm modifying here slightly. Now, remember that when you factor out a -1, that negative sign has to go someplace. There are basically 3 places you can put it. You could put it out front of the 5x right here, so you have a minus 5x. You can basically change this addition sign to a subtraction sign. That's a possibility. Or you can just put it up here by the 9. I'm going to put it up there by the 9 because, to me, that's sort of the easiest thing to do. Plus, there's something else I should tell you. You don't want to keep it down here by the 5. If you keep it down here by the 5, it's still in the denominator, which means it gets sucked into that LCD, making it more complicated. So when you factor out a -1, you want to get the negative sign out of the denominator. So either put it by the 9, like I'm going to do, or maybe make this addition sign a subtraction sign. One of those two options would be preferable than keeping it down below. So I'm just going to put it by the 9 because that to me is a nice, simple thing to do with it. Now, the denominator, all it's going to change is I'm going to flip that around and make it x minus 3. That was the whole point of all that. Now if these guys are identical, I only need one of them in the LCD. Now this problem has something else to show us besides what we've done so far. So this is one idea, one trick that you want to keep your eyes open for. Here's something else. It has to do with this first piece right here. You can't really tell it at the moment, but if you go in here and analyze this a little more carefully, take a look at this numerator, maybe fiddle with it for a moment, you're going to see something happen that definitely, again, works to our advantage. Let's go ahead and factor that numerator, see where it leads us. If I factor a 4 out of that numerator, it's going to take a 4 out and leave behind what? X plus, and then 4 times 3 is 12. Notice you have an x plus 3 on top, and we have an x plus 3 down below. So what can I do with those two x plus 3's at that point? Yeah, we can cancel them, can't we? And that works to our advantage. Why? Because one of the big differences between these two denominators is this x plus 3. If I get rid of it, which is what happens when I cancel, now these two denominators are even closer to being together, being the same thing. In fact, if I could make these two denominators identical, that would be your common denominator. I can't quite go that far, not yet, not without multiplying, but I'm getting really close to it. That is sort of the issue we're addressing with all this effort, and that is to do the best you can to make the two denominators as similar to each other as possible. And then once you've played that out as far as it'll go, then start doing the multiplication game of making, changing one of the denominators into something else to make it equal to the LCD. But you get them as close as you can to each other before you do that. But we've driven that as far as it can go. And now what's our LCD going to be here? The LCD is going to be what? 5x minus 3, is it? Because I need at least the second denominator, and it's already got the x minus 3, so that's all I need. That's pretty good. Because as I go to the next step here, where I'm going to write that down, I have this 4. Let's go ahead and just rewrite what I have here so you can see it. 4 over x minus 3 plus negative 9 over 5x times x minus 3. There you go. All I got to do is modify this first piece by multiplying top and bottom by what? 5x? There you go. And that'll make them identical. Okay. So what does that give us? That gives us, in the end, 20x and then 5x times x minus 3. The second piece, it's already got everything, so I don't have to worry about that. So just keep it the way it is. Now I've run out of room here, so let me go ahead and just erase all this, and we'll take this stuff right here, and that'll be our starting point at the top. So allow me to erase all this, then we'll write that down. Alright. Be nice if I could just scroll the board down. I can't, though. It's a physical object that doesn't scroll on a screen. But here's what we end up having then. We end up having this 20x on top. Well, let's go ahead. I'll go ahead and just copy what I had before, just to make sure we had 4 over x minus 3. And then it's plus negative 9 over 5 x times x minus 3. The LCD there was 5x times x minus 3. I'm just replaying the bottom of that part that we just worked on. We have more room here. So now the LCD becomes 5x times x minus 3. And I got to multiply this first guy by 5x over 5x. And so that gave us 20x there. The second piece already has everything, so I don't have to change it. All right, so that's basically where we were at the bottom there. Just kind of picking up where we left off there. Now, combine, right? Bring them together. Single. I don't think I have to be that big about it. There we go. Single denominator, one fraction. They're probably not going to write this as plus negative 9 because that looks kind of silly. They'll probably write it as what? Just minus 9. There you go. And notice it's in lowest terms, isn't it? There's no way to factor and cancel that. You can't factor anything out of the numerator. That's not going to happen. And so there's nothing to cancel. And it's in lowest terms, and there's the answer. So we put a lot of effort into making that LCD as small as we possibly could, but that really pays off big time toward the end. If you don't do that, if you don't say spin that one piece around by factoring out negative 1 and catch that, if you don't do it that way, or if you don't do the factoring and canceling, then the LCD will be more complicated. You can still get to the answer, it's going to require a bit of factoring and canceling toward the end of the problem. So you're going to pay the piper one way or the other. My recommendation is to pay the piper at the beginning of the problem and make your LCD as simple as it possibly can be. That generally is the better strategy because it'll avoid the possibility of getting you into a factoring situation at the end that might be a little more complicated than you can handle at this point. At any rate, I find that to be the preferable strategy. Get that LCD to be as simple as it possibly can be, and it pays off nicely at the end. I would just take you through one more example here. This last one won't be really that bad. Not as bad as that one. The one we just did there's probably the worst of the bunch. But let's just finish this off with one relatively nice example. What's a little different about this particular example that we'll look at right now is it's got 3 pieces in it. But like I said, it's not that bad of a problem. easier than the last one we just did, to be sure. Okay, so we want to combine these together. We got these three rational expressions, three fractions now. We notice this last denominator can be factored, so we'll begin by getting that factor before we try to pick off the LCD, because you always want your denominators factored first before you try to pick off any LCD. There we go. Now, what's the LCD for this problem? I don't think it's too hard to spot, right? You basically have a y and a y minus 2. This has got them both together, but that's the LCD then. So y minus 2 is the LCD. It's the smallest thing that all three denominators can go into. Okay. So now write that down as the common denominator. Too much there. All right. There we go. So it's the common denominator now for all three pieces. And then play the multiplication game. What do you multiply y minus 2 by to turn into y times y minus 2? You need a y, of course. And whenever you do the denominator, do the numerator. So you got 5y on top. Not too bad. Now the second piece here, what do you multiply y by to get y times y minus 2? Y minus 2, again, not too hard to see that. Again, the multiplication game is not difficult to play. It's just it's what you do after you get the denominators laid down according to the LCD, then it's going to modify those numerators properly. And it's driving in the right direction. And finally, the last piece, don't have to do anything to it, right? It's already got the correct denominator, so it's already got the correct numerator. Don't have to do a thing to it. Now, bring these all together. You probably could just add these in your head. If that's a little too sketchy for you, a little too risky, you could write them out like I'll do here. It's up to you. On some problems, I would definitely write it all out because I don't want to take the chance, but in this case, it's not too complicated. You might just add them up in your head there. Anyway, I'm writing them out, so it's not too hard to follow, for sure. All right, so what do we have on top there? If you start combining like terms, you got 5y and y is 6y. And what happens to those 2's? The 2's cancel out, don't they? Negative 2 and positive 2, they cancel out, so you just got 6y on top at that point. And can you do any canceling? Yep, sure can. A little bit of canceling here between this y and that y. So if we can follow that, and what does that leave in the end? You got the 6 on top, and the y minus 2 by itself down below there. Nothing else going on. There you are. Lowest terms, single fraction, lowest terms, as always. That's what we're shooting for. And there you go. So the examples in this video, in particular, are the most challenging. It's sort of the goal of these problems. That's the level you're shooting for. And I'll put a couple of problems on the test that are kind of like these. I'm not going to make it crazy difficult, but pay attention to the techniques that you see in these examples. How we're reducing the lowest terms at the end, how you might catch factor out -1 or something else that can work to your advantage. Those examples are definitely showing you things to be watchful for. Tips, tricks, techniques, subtle points, whatever you want to call it, that you want to keep in mind as you work these problems. And of course, all of them are going to emphasize the need to be very careful in order to successfully grind your way, navigate your way all the way through a problem. Because it's got to be perfect. You can't make a mistake, otherwise you just never get to that answer. So what can I say? Good luck. Of course, if you get stuck, let me know, and I'll help you with whatever issues you're having.